Growing rectangles, a rich mathematical problem that uses the concepts of scale factoring and area to teach grade 4 students multiplication.
Imagine a rectangle with an area of 20 centimeters squared. What could its length and width be? List at least 5 different combinations. Next, imagine enlarging each of your rectangles by a scale factor of 2. List the dimensions of your enlarged rectangles and work out their areas. What do you notice? What happens to the area of a rectangle if you enlarge it by a scale factor of 3, or 4, or 5? What happens to the area of a rectangle if you enlarge it by a fractional scale factor? Can you come up with a formula for area when enlarging a rectangle by a scale factor of any number?
The concepts of scale factoring, area, geometry, and units are all present in this problem. A third dimension can be added and the same exercises can be used for investigating volume. Also, this problem allows for extensive mathematical exploration because students are trying many equations and observing patterns from their explorations. These topics are represented in the Alberta Mathematics curriculum for grade 4 and beyond. This problem also provides the first steps for creating algebraic equations when you use a variable as a scale factor instead of a number.
We find length and widths of 5 different rectangles with an area of 20 centimeters squared. These are 5 dimensions we came up with. Students may not recognize that rectangles oriented differently can have the same dimensions. Then we enlarge each rectangle by a factor of 2. Students must remember to multiply both the length and the width by 2. Then the students can calculate the area. If we calculate the area of all the rectangles, we can notice a pattern. When we increase the scale of each rectangle by a factor of 2, we notice the area increases by 4. When we increase the scale by a factor of 3, we notice the area increased by 9. A scale factor of 4 increases the area 16 times, and 5 increases the area by 25. A fractional scale factor of 1/2 decreases the area by 1/4. Students can then observe that area is affected by the scale factor squared.
The first concept in our problem is scale factoring. In this concept, we can view multiplication as a metaphor of comparison. For instance, you can view a problem such as 2 times 3 equals 6. But using the metaphor, you can also view 6 as being 2 times as much as 3. So if you start off with 3 smiley faces and you want 2 times as much, you would multiply 3 by 2 and end up with 2 groups of 3 for a total of 6 smiley faces.
The second concept in this problem is area. Area represents the space inside the edges of any shape. We can view multiplication as a metaphor of raising a base length to a specific height and discovering the value of the space within the confines of the new shape. If the base is 5 centimeters, raise that base to a height of 4 centimeters, so the value of the space within is 20 centimeters squared.
The practice problems use the same outline as the original problem. Here we use geometric shapes other than rectangles. We use an isosceles triangle with an area of 6 centimeters squared. Students can find several combinations of base and height to achieve a triangle of that area. When we use a scale factor of 0.5, the area decreased to 1.5 centimeters squared.
Here we use the example of a cube. This practice problem adds a third dimension to our shapes to involve the concept of volume. The dimensions of the cube are 4 centimeters on all sides. We found the volume of 64 centimeters cubed, and when we used the scale factor of 0.5, the volume decreased to 8 centimeters cubed.